Okay, here we are, exam 2. First question, use the discriminant to state whether the quadratic equation has 2 real solutions. So that means it's greater than 0, 1 real repeated solution, that means it's equal to 0, or 2 complex solutions, that means it's less than 0. So remember, the discriminant is b squared minus 4ac, that's the part underneath the square root. So if the part underneath the square root is positive, you're going to get real numbers. If it's negative, you're going to get imaginary numbers. And if it's equal to 0, you're going to get a nice fraction with no square root. So let's see here. So we've got 4 squared minus 4 times 3 times negative 9 gives us 16 plus 108, which gives us 124. So since that is a positive number, we have 2 real solutions. All right, next, evaluate the determinant. This is something that we did not have time to do in class, so I'm going to very carefully show you how to do this now. When you have a 3 by 3 matrix like this, we say it's 3 by 3 because it has 3 rows and 3 columns. To take the determinant is a way of measuring the size of a matrix. There's a few different ways that we can measure the size of a matrix, and the determinant is one way, and it's one of the most popular ways. There's actually a lot of things that we can learn by using the determinant. We can look at area and volume, but that's something that if you decide to take a class called linear algebra, you will study later on in math. But for now, we're going to learn how to do a determinant so that you can use that knowledge later on. It's also very useful in solving systems of linear equations, so we'll talk about that as well. Okay, so what do? We copy down the first 2 columns and we place them to the right of the matrix. So we've got 1, -3, 0, that's column 1 recopied, and then 2, 3, -2, that's column 2 recopied. And what we're going to do is we're going to start in the top left corner and we're going to look at the diagonals going downward. And we are going to multiply the numbers in those diagonals. So 1 times 3 times 1. 1 times 3 times 1. And then to it, we're going to add the next diagonal, 2 times 0 times 0. And then we're going to add the last diagonal, 4 times -3 times -2. All right, and then this is going to all be added together. And from this, we're going to subtract another big expression. So what we're going to do is we're going to start in the bottom left corner, and now we're going to multiply going up the diagonals. So we've got 0 times 3 times 4. And then we're going to add -2 times 0 times 1. And then we're going to add 1 times -3 times 2. So remember that. All 3 diagonals get multiplied and get added together. So that's true for both sets of diagonals, and then there's a minus sign in between. And you have to be super careful. You have to start in the top left corner and you have to multiply going down first, and then you subtract the result you get from multiplying going up. So down first, then up. So you need to remember that. Okay, so let's work this out. We've got 3 plus 0 plus 24 minus 0 plus 0 plus negative 6. So what does that get us? We've got 27 minus negative 6. So that's going to give us 33 as the value of the determinant. If you want to do more determinant problems, what you can do is look up on Google matrix calculator and make up a determinant for yourself. Make up a 3 by 3 and then plug it into the matrix calculator and click on calculate the determinant, and then check and see if your answer matches. So you can make up anything you want as a matrix, a 3 by 3 matrix. Put at least a 0 and a 1 in there and make it easy for yourself, and do some practice. All right. So number 3, solve the following system by any method. I showed you a method already in which we use elimination to knock out certain variables. So what I want to do instead is show another method called Cramer's rule. So Cramer's rule says, let's look at all of the coefficients we've got going on here. So I'm going to call this A1x plus B1y plus C1z equals D1. Because that's our first equation, so everything has a subscript of 1. Likewise, we've got A2x plus B2y plus C2z equals D2. So that's our second equation. And so it has a subscript of 2. And then finally, A3x plus B3y plus C3z equals D3. So we match up the coefficients with the A's, B's, C's, and D's. So I'm going to write Cramer's rule written in a general form, and then it's up to you to take the specific coefficients from the problem and plug it into the right places. So to find the x value that is the solution to this system of linear equations, we're going to make a fraction, and we're going to have 2 determinants on the top and on the bottom. On the bottom, we're going to have all of the coefficients that are in front of the equal sign. So A1, B1, C1, A2, B2, C2, and A3, B3, C3. That's going to be the bottom matrix. And if we were to solve for y, it'll be the same thing, a determinant top and bottom. And for y, it's going to be the same exact matrix on the bottom, A1, B1, C1, A2, B2, C2, A3, B3, C3. And same thing if we wanted to solve for z. So if we want to solve for z, again, it's going to be a fraction, determinant on the top and bottom, and A1, B1, C1, A2, B2, C2, A3, B3, C3. So the nice thing about Cramer's rule is that once you calculate this determinant and you do it once, you have it for all 3 variables. Okay, so that's the bottom determinant. It's the same for all 3, and it's going to be all of the coefficients that come before the equal sign. Okay, so what about the top determinant? So when you're solving for x, your D column is going to replace the A column because that is the set of coefficients that's with X. So instead of A1, A2, A3 going down, it's going to be D1, D2, D3 going down. So D is going to take the place of A, and then everything else stays the same. The B column stays the same, and the C column stays the same. When you're solving for Y, your D column is going to take the place of your B column. So in the middle, we're going to have D1, D2, D3, and then everything else is going to stay the same. So we've got A1, A2, A3 to the left, and C1, C2, C3 to the right. And then for Z, you may have guessed, the D column is going to replace the C column. So we've got D1, D2, D3 in the last column, and then the other two stay the same. A1, A2, A3, B1, B2, B3. Okay, so let's work out some determinants. So I'm going to put an equal sign here. And we've got all this space to do our work. So let's do the determinant, let's do the bottom determinant first. So what we can do is say we've got 3, minus 2, 1, minus 2, 4, minus 1, and minus 1, positive 1, positive 3. So that's the matrix of the what we'd call the coefficient matrix, all the coefficients in front of the variables. Okay, so just like above, we're going to copy down the first two columns. So 3, minus 2, 1, minus 2, 4, minus 1. I would recommend right now that you pause the video and try this on your own. See if you can follow the steps that we did above, and then check your answer with what I do. Okay, so we're going to multiply down the diagonals first. So we've got 3 times 4 times 3, that's going to be 36, plus negative 2 times 1 times 1, that's negative 2. Negative 1 times negative 2 times another negative 1, that's going to be a negative 2. All right, then we've got the minus sign in the middle, and we've got another set of parentheses, and now we're going to multiply up the diagonals, starting from the bottom left. So 1 times 4 times negative 1 is negative 4. Negative 1 times 3 is negative 3. And 3 times negative 2 times negative 2 is going to be a positive 12. So that gives us 32 minus 5, which is going to be 27. Okay, so our denominator, we now know in every single case, is 27. Okay, now let's compute this top determinant. So what we're going to do is we're going to replace the A column by everything in the D column. So our first column is going to be negative 10, 13, and 6, and then negative 2, 4, negative 1, negative 1, positive 3. Oops. Okay, so next we copy down the first two columns. And start multiplying. So we start in the top left and multiply down. So negative 10 times 4 times 3 is negative 120. And then negative 2 times 1 times 6 is negative 12. And then negative 1 times 13 times negative 1 is 13. Minus sign in the middle. Now we multiply up the diagonals. 6 times 4 times negative 1 is negative 24. Negative 1 times 1 times negative 10 is positive 10. And 3 times 13 times negative 2 is negative 78. Okay, so what have we got here? We've got negative 119 minus negative 98. Hang on one second. I'm going to grab my calculator to just double check. Okay, no, I was wrong. So it's negative 92. So negative 119 minus negative 92 is going to give us negative 27. All right, so we've got a negative 27 up there. That tells us that x is equal to negative 1. All right, let's try it also for y. So this is good practice again in just doing some determinants of a 3 by 3 matrix. So for y, we're going to leave the a column the same, 3 minus 2, 1. Now the b column is going to change. It's going to be negative 10, 13, and 6. And then the c column stays the same, negative 1, positive 1, positive 3. Okay, so again, pause the recording, try it yourself first, and then let's see if our answers agree. Okay, so we're copying down the first two columns, multiplying down the diagonals, and we've got 3 times 13 times 3. So that's going to give us 117, and then negative 10 times 1 is negative 10, and then negative 1 times negative 2 times 6 is going to give us a positive 12. Minus sign in the middle. Now we multiply up the diagonals. 1 times 13 times negative 1 is negative 13. And 6 times 1 times 3 is a positive 18. And then 3 times negative 2 times negative 10 is a positive 60. So that's going to give us 119 minus 65. And that is going to give us 54. So the top is 54. Now we've got 54 over 27, so that tells us that y is equal to 2. And it's really your choice now. If you want to do another determinant for z, you can. Or, since you know that x is equal to negative 1 and y is equal to 2, you can actually just plug them into any equation up here and solve for z. So that's actually what I'm going to do for z. I'm going to do it in this little space right here, and I'm going to plug it into this bottom equation. So we've got negative, let me do it up here so I can work out some steps. Negative 1 minus 2 plus 3z is equal to 6. So we've got negative 3 plus 3z is equal to 6. 3z is equal to 9, and z is equal to 3. So now we have a solution to this. Our solution is the point negative 1, comma 2, comma 3. And we got some good practice in working with determinants. All right. Again, if you want to go back, you can also solve this by elimination. Again, you would pick two equations, and let's say we want to knock out z from those two equations, right? That's nice because we can just add them together and z will cancel. Then we pick two other equations, the first one and the third one maybe, or the second one and the third one, and we eliminate z again. And then what happens is we've got two new equations just in x and y, and then you can use those two equations to solve for x and y and then plug in for z. So that's another option. And you've also got Cramer's rule if you happen to like doing determinants, which some people do. Okay, on to the back. Find the equation of the line that is perpendicular to y equals 3x plus 1. Okay, so first of all, perpendicular means that they have negative reciprocal slopes. So for example, 4/3 and -3/4. They're reciprocals of each other, and they're also negatives of each other. Okay, so what does that tell us? That tells us that if this slope is 3/1, then the slope of our perpendicular line is going to be -1/3. And the equation of the line is y equals mx plus b. We have an x, we have a y, and we have an m. So all we need to do is plug in everything and solve for b. So we've got 3 is equal to -1/3 times 6 plus b. That tells us that 3 is equal to -2 plus b, and 5 is equal to b. So the equation of our line is y equals -1/3 x, because -1/3 was the m that we found, plus 5, because 5 is our b. So that's what you really just need to remember. Perpendicular means negative reciprocal slopes. Once you have the slope and you have an x and a y point, you can just plug straight into y equals mx plus b, solve for b, and you've got the equation of your line. Okay, next, number 5. So we've got a system of equations, and I'm asking you to just evaluate at certain points. So when x is equal to -3, we've got -3 plus 3y equals 3. So 3y equals 6 and y equals 2. When x is equal to 0, then we've got 3y equals 3 and y equals 1. When y is equal to 0, we've got x equals 3. And when y is equal to 3, we've got x plus 9 equals 3. So x is equal to -6. It's a similar thing for letter B. So when x equals -2, then we've got -2 times -2, so that's a +4, minus y equals 1. So that means that -y equals -5, or y equals 5. When x equals 0, we've got -y equals 1. So y equals -1. When y equals 0, we've got -2x equals 1, so x equals -1/2. And when y equals 2, we've got -2x minus 2 equals 1, so -2x equals 3, and x equals -3/2. So it's just a little bit of plugging in and doing a little bit of algebra. Okay, So, number 6 says use substitution, elimination, or Cramer's rule to solve the system of equations. For me personally, I always like elimination probably about 90% of the time. I think it's going to be easier. So what I'm going to do is I'm going to take the first equation and I'm going to multiply it by positive 2 to put a 2 in this space, so it cancels with this negative 2. So multiplying that equation up there by 2 gives us 2x plus 6y equals 6, and then we copy down the other one underneath, minus 2x minus y equals 1. Okay, so the x's cancel. We've got 5y equals 7, so y equals 7/5. And then we can plug in for x. So I'm going to plug back into that first equation again. X plus 3 times 7/5 is equal to 3. So now I'm going to change everything into a fraction. So we've got x plus 21/5 equals 15/5. And now subtract 21/5 on both sides. So x is equal to negative 6/5. So our point that is our solution is negative 6/5, comma 7/5. Okay. Question 7. Use the points you found to graph both lines on the same graph and indicate the point of intersection with a star. So, going back to our table, both of them at once. Okay. Here we go. So, going back to our table, we've got various x and y points. So, let's just plot those. Negative 3, 2, 0, 1, 3, 0, and negative 6, 3. All right, there's our first line. So this is line A. Next, line B. We've got negative 2, 5, 0, negative 1, negative 1/2, 0, and negative 3/2, 2. Okay. That one's a little bit more difficult to draw in, but still doable. So there's line B. And our point of intersection is, again, negative 6/5, comma 7/5. So they're both just a little, they're close to 1. So it's close to negative 1, 1, which we can see on our graph. It is close to negative 1, 1. It's not exactly, but our graph definitely matches up with what we found algebraically, so that's always a good thing. All right, so there's our point of intersection, and there's our lovely star. Okay, next. We've got a chart problem. So let's read through this carefully, and let's fill in the information in the chart as we go. A person invested a total of $23,500 into 2 bonds. So we might be tempted to think that goes in total amount, but that's not actually quite true. So let's just keep reading for a second. So a person's investing money into 2 different bonds. One has an annual interest rate of 6% and the other has an annual interest rate of 2%. If the total amount of interest earned from the two bonds is $914. How much was invested in each one? So we've got an interest rate times some number of dollars. So this number means the number of dollars we're investing in that bond. And that's going to give us the total amount of interest that we earn on that bond. So our first interest rate is 6%. So I'm going to write this as 0.0600. And again, I gave you 3 significant digits here, so it's important to keep those when you turn this into a decimal number. So we've got an interest rate of 6%, and we don't know how much we invested here. So I'm going to call this X. And so the total amount of interest we earn is 6% of whatever X is. We just multiply them, right? So I've written rate times number equals total amount. So what we're doing across the rows is just multiplying. So for bond 2, we have an interest rate of 2. And we, again, don't know how much we invested there, so we're just going to call it Y. And the total amount of interest we earn is 2% of whatever Y is. Okay, so what else do we know? We know that the total number of dollars invested was $23,500. And we know that the total amount of interest earned is $914. So now what we've got is a system of equations that we can solve. We know that X plus Y is equal to 23,500. And we know that $6 of X plus 2% of Y is equal to 914. And you can solve this any way you want. Again, I'm going to use my favorite method of elimination. And usually when I use elimination, I like to look at the coefficients in the other equation, and I like to take out the variable that has the smaller coefficient. And what you do when you do this is that you make sure that you're working with positive numbers. I don't like working with negative numbers. Most people don't. We'd rather work with positive numbers if we can. So by taking out the smaller coefficient, you're guaranteed that you're subtracting a smaller number from this bigger coefficient instead of the other way around. I'd rather subtract 0.02 from 0.06 than I would subtract 0.06 from 0.02 and end up with a negative 0.04 to have to deal with. So that's just one little tip to doing these sorts of problems. So I'm going to multiply everything by negative 0.0200. All right, so what do we get? We've got negative 0.0200x minus 0.0200y equals, and I'm going to need my calculator for this one, 23,500 times 0.02 gives us negative 470. Okay, so the y's cancel. We've got 0.0400x is equal to 444. We divide both sides by 0.0400, and thinking back to significant digits, this has 3, this has 3, so our answer is going to have 3. So 444 divided by 0.04 is going to give us 11,100, and that's great because that does have 3 significant digits. Remember that these 2 zeros at the end are not significant. And so we know that X was 11,100 $100. So that went into bond 1. And so if there was a total of $23,500, we just have to subtract the amount that X was to get Y. And so we end up with $12,400. All right. Next, we've got evaluating functions. So I just want you to basically plug in different x values into f of x, and let's see what we get. So f of minus 6 is going to be 5 over minus 6 plus 1. So that's 5 over minus 5, which is negative 1. F of minus 2 is going to be 5 over minus 2 plus 1. So that's going to be 5 over negative 1, which is negative 5. F of 0 is 5 over 0 plus 1. That gives us 5 over 1, which is positive 5. F of 1 is 5 over 1 plus 1, so that gives us 5 halves, or 2.5. F of 4 gives us 5 over 4 plus 1, so that's 5 over 5, which is 1. And then f of 9 is 5 over 9 plus 1, that's 5/10, which is equal to a half. Okay, so let's use the points we found in question 6 to sketch a graph of f of x. So remember that this is a rational function, and it's going to have like that hyperbola kind of a shape with the horizontal and vertical asymptotes. So we know that it has an asymptote at x equals negative 1. We can actually write that in right now. We'll put a dotted line here to indicate this is the place where the function is undefined and it has a vertical asymptote. Then we've got the point negative 6, negative 1. We've got the point negative 2, negative 5. We've got the point 0, 5. We've got the point 1, 2.5. We've got the point 4, 1. And we've got the point 9, 1/2. So this is going to stretch up like this towards infinity, and this is going to stretch down towards the x-axis. And it's going to be symmetric on this side, so we can kind of just draw that in. So this is going to stretch down towards the asymptote, and this is going to stretch up towards the x-axis. So there's our graph of f of x. Okay, our next questions are related to this graph and this function. So question 11 asks, what is the domain of f? So let's just put f back up on the screen along with this question. Okay, what is the domain of f? Well, if we look, it's anywhere where we don't divide by 0. So basically pretty much everywhere except x equals negative 1. So we could say all real numbers except x is not equal to negative 1. Or we could write it as negative infinity to negative 1 union negative 1 to infinity. Anything that conveys the idea that you know what you're talking about is fine by me. What is the range of f? Well, again, remember the range is all the y values. So if we go back to our graph, our y values stretch up to positive infinity, and they stretch down to negative infinity. The only y value that doesn't ever get used is y equals 0, because the graph is going to get really close to the x-axis, but it's never going to actually touch the x-axis. So y equals 0 is a y value that doesn't exist for this function. So we could say that the range is all real numbers except y is not equal to 0, or we could say something like negative infinity to 0, union 0 to infinity. All right. Let's do some more stuff with functions. So I want you to evaluate some functions and find the composition of some functions. So first, f of h of x, that's going to be f of x squared plus 2. So wherever we see x, we're going to plug in x squared plus 2 instead. So that's going to be 2 times x squared plus 2 minus 1. So if we do a little distributing, we've got 2x squared plus 4 minus 1. So that's 2x squared plus 3. Find g of h of negative 3. So first let's find h of negative 3. So I'm going to do that over here. H of negative 3 is negative 3 squared plus 2. That's going to give us 9 plus 2, so that's 11. So what I really want to find now is g of 11. That's going to be the absolute value of 11 plus 1, so that's the absolute value, whoops, that's the absolute value of 12, and that's just 12. Find h of y plus 1. So that's going to be wherever we see x in the formula, we're going to plug in y plus 1 instead. So we've got y plus 1 all squared plus 2. Remember, you need to FOIL this guy. This is a perfect square trinomial. So this is going to be y squared plus 2y plus 1 plus another 2 at the end. And that gives us y squared plus 2y plus 3. All right, and then the last one, find h of g of f of negative 1. So let's start on the inside and work our way out. F of negative 1 is 2 times negative 1 minus 1. That's negative 2 minus 1, which is negative 3. Okay, so this now is h of g of negative 3. So now we have to do g of negative 3. G of negative 3 is the absolute value of negative 3 plus 1. That's the absolute value of negative 2, which is going to be 2. Okay, so now that gives us h of 2. And h of 2 is going to be 2 squared plus 2. That's 4 plus 2. And our final answer is 6. So composition of functions, not so bad. You just have to plug in very carefully, really, and just watch your signs. So yeah, there's that. Next, we've got a lot of different pictures of functions. So we've got this polynomial type of a function. We've got this rational type of a function. We've got a parabola that's on its side. We've got some other polynomial going on over here. We've got a straight line, and we've got a parabola. Okay, so we've got all these different kinds of functions, and I asked you some questions about them. So the first one, which graphs are functions? Which are one-to-one and which are onto? So we need to do a few definitions. So first of all, which graphs are functions? So how do you know if something's a function? It passes the vertical line test. So let's go back to the pictures. And in letter A, no matter where I draw a vertical line, it's only going to intersect the graph once. That's what we're looking for. The definition of a function is if I draw a line through some x value, it's only going to have one y value associated with it. So this one is a function. This one's good. Same thing here. No matter where I draw a vertical line, it's only going to intersect the graph at one y value. This one's a function. This one, however, if I draw a vertical line, it intersects the graph at two different y values. So this one is actually not a function. Letter D, same thing. We can draw vertical lines wherever we want. It's only going to intersect the graph in one place. Letter E, same deal. We can draw a bunch of vertical lines. And letter F, same deal. We can draw a bunch of vertical lines. So the only one that's not a function is C. So which graphs are functions? A, B, D, E, F. Okay, which ones are one-to-one? So the definition of one-to-one, or one of the definitions, is that it passes the horizontal line test. So if a function is one-to-one, it means that given a y value, there's only going to be one x value that matches up with it. That means that's what it means to be one-to-one. So given an x value, it has only one y value, and given a y value, it has only one x value. Those two values are one-to-one. There's no other coordinate that uses those two exact numbers. So we can test this with the horizontal line test. All right, so now let's go back to letter A. If I draw a horizontal line here, it's going to intersect the graph in three different places. So if, let's say this is y, it's not quite 1, but let's just say this is y is equal to 1. Well, if y is equal to 1, x can be a whole lot of different things. It could be any one of these 3 points. So it's not one-to-one. There's 3 different x values that all have the same y value. So as far as one-to-one goes, that's going to be a no. If we look at letter B, these are all going to have, these different y values are all going to have different x values. It passes the horizontal line test. So B is one-to-one. C isn't even a function at all, so it doesn't even make sense for us to talk about one-to-one or onto, because those are only things that functions can be. So if it's not even a function, it doesn't even make sense to talk about one-to-one or onto. So we're not even going to worry about C. It can't be either one-to-one or onto because it's not even a function anyway. Letter D, this one fails the horizontal line test. There's multiple places where you can draw a horizontal line where there's going to be more than one x value that intersects your y value. So D, not one-to-one. E is going to be good. We can draw all the horizontal lines forever and ever, and it will always pass. And then F is going to fail because it has multiple spots where you can have the different x values for the same y value. Okay, so the only ones that passed the horizontal line test were B and E. Okay, and then which ones are onto? The ones that are onto, so onto means it, so the range is all of R. So basically it, or you can say it uses the entire y-axis. So every point on the y-axis is accounted for. So every real number is associated with some coordinate on the graph, basically. So which ones are onto? Well, if we look at A, this goes all the way up to positive infinity, and it goes down to negative infinity, and we've got all the values in between. So this one's onto. It uses all the numbers for its y coordinate. This one is almost onto, but you can see we've got a horizontal asymptote. here at the x-axis. So y is not equal to 0. That's a problem. So because it doesn't use every single real number, it's not onto. C is not a function. We're not even going to worry about it. If we look at D, this stretches down to infinity. This stretches down to infinity. The highest point of the graph is here. So any y values that are up above here aren't going to be used. So that means that we're missing a whole bunch of y values. That means that the range is not all real numbers, which means that this graph is not onto. If you look at letter E, this stretches up to infinity. This stretches down to negative infinity. We've got all the numbers in between. This graph is onto. And then the last one, same deal here. All of the negative y values are not being used. So this graph is not onto. It looks like our only ones that are onto are A and E. So A and E. Okay, good. So that's one-to-one and onto. Hopefully that was a refresher for you. Okay, next. Find the equation of the line that is parallel. So that means the same slope to this line. So we know m is equal to 5/2. They have the same slope. We have an x and we have a y. And just like last time, we're going to plug into y equals mx plus b. We know y is 5. M is 5/2. X is 4 plus b. So we've got 5 is equal to 10 plus b. Negative 5 is equal to b. And so our final equation is y is equal to 5/2 x minus 5. Boom, done. Okay, and you may be curious about this bonus problem that I gave to my students, so I'll just give you the answer. So the car shifted gears by itself. Why wasn't he concerned? There were a few valid answers. Some people who put he just didn't care. I gave them partial credit for that. Maybe he just didn't care. But the answer is because he was driving a car with an automatic transmission. So, yeah, so it's going to shift gears by itself, and it's supposed to, and that's why he didn't care. So, okay, that's the end of test 2. I will be back with test 3.